this is flying into trig on a paper plate. All right, now if you missed today's lesson or you weren't in school, this is your opportunity to create your paper plate following directions online. If at some point you get lost, you can go back, listen to it, rewatch it. You can always come and ask questions after school. This particular lesson is not a new lesson. It's not new material. It is what we already did in the unit circle lesson, but it's a further hands-on opportunity to see what's going on and to get a feel for the unit circle. So, first things first. Some of this I can't go quite as slow as I do in person because I don't have to show the whole thing all at once. But you've got a paper plate. And the first thing you want to do is flatten it out as much as possible. The official directions say to iron your paper plate. I don't know if that's a great idea. If it has any wax coating on it, it's going to mess up your mom or dad's iron. They're not going to be happy about that. If you leave it on there too long, you might burn it. Still not a good idea. So I'm thinking ironing's not the best way to flatten your paper plate. Instead, go to the edge of a table or a counter that's got a sharp 90-degree angle and just run it back and forth. Grab either side. Grab down here, grab up here, and then run it up and down, back and forth over the edge, and that'll help to flatten it out. It's highly unlikely you'll get it 100% flat, but you can try. Now, once you have your paper plate as flat as possible, what you're going to do is you're going to fold it in half, and then you're going to fold it in half again. Okay? What you want is to fold your paper plate in half and then half again so that it looks like this guy up here. Once you're done with that, unfold it. Once it's unfolded, then what I'd like for you to do is to take and color the edge. Color the edge around the outside. Okay? That's best done using, like a sharp highlighter. And then along the folds that you created, do an X and a Y axis. These are going to be your X and Y axis. You can make it dashed or solid. This is your X and your Y axis. Pause the video and do that. Okay, now you've got your X axis and your Y axis. You want to label them as the X axis and the Y axis. And this point in the center here, that's the origin. That's also 0, 0. So you can put a 0 here. This is kind of what your plate should look like at this point. Now, and again, part of what you miss in class is some of the discussion and the question and answers that I have going back and forth, but it's kind of hard to do that via the video. So we're just building your paper plate so that you'll have it when we use it in class. Now, what we did is we went around and we talked about, after we finished step 1, how a unit circle, the radius is 1. And since the radius is 1, then this point out here, okay, and by the way, this is a circle. The plate is a circular region. So this point on the edge of the circle is the point 1, 0. It's at 0 radians. This is also our anchor point because our initial side for every angle starts on the positive x-axis. When we move up to pi over 2, this point is at 0, 1. Then at negative 1, 0, we have pi. And at 0, negative 1, we have 3 pi over 2. Notice that 2 pi, we've already talked about, is all the way around the circle. So we have 0, half a pi, pi, 3 pi over 2, or 1.5 pi, and 2 pi. You want to have it all labeled. Okay? Now, this next part. These are some questions that we'll talk about in class. If you trace the length of the arc, okay, and let me see if I can find my flying into trig on a paper plate directions. Oops, there we go. If you trace the length of an arc from A, the anchor point, all the way around the unit circle back to A, what is the length of the arc traced? Well, if you think about your unit circle, okay, it's 2 pi. 2 pi is when you go all the way around. Hang on just a second, because I want to make sure. What I'd like to do is show you the circle and read the questions, but give me just a moment to find my question. Okay, this is a little bit better. So if you trace the length of the arc from the anchor point all the way around, okay, the circle back to A, then you have gone how far? Good, 2 pi. If you trace the length of the arc from A to where the y-axis intercepts the unit circle in the positive, you've gone pi over 2. If you go from A to the negative x-axis intercept, you've gone pi. If you go from A all the way to the negative y-axis, you're at 3 pi over 2. So from here all the way around is 2 pi. From here halfway, that's our pi over 2. Over to here is pi radians. And down to the negative y is 3 pi over 2. Notice we're all going in the positive direction. The length of OA from O to A is 1. Okay? The initial point. What is the initial point of all the arcs? If you said A, you're correct. How would you describe, think about this, how would you describe the terminal point? Well, the terminal point is the point on the unit circle that is on the terminal side of the ray or of the angle. Okay? All right. So that means we have answered these questions. Next up, we have group activity 2. So I'm going to go through these questions. If you want, you can take a screenshot of these. And then I'm going to go through and answer these, again, looking at the paper plate. So looking at the paper plate, what is the length of OA? OA is equal to 1. What are the coordinates of the point where the positive y-axis intercepts the unit circle? Well, that's 0, 1. What are the coordinates of the point where the negative x-axis intercepts the unit circle? Negative 1, 0. What are the coordinates of the point where the negative y-axis intercepts the unit circle? If you said 0, negative 1, you're right. What are the coordinates of the terminal point of the arc length 3 pi over 2? Well, first you have to ask yourself, 3 pi over 2. I start at my anchor point and I go all the way around to 3 pi over 2. So this is my angle. What is this point? That's 0, negative 1. What are the coordinates of the terminal point of the arc length of pi? Well, if I start here and I go round to pi and I end here, those points are negative 1, 0. Okay, those are things that you're being asked. So it's a lot of repetition, but it's getting yourself used to and very, very comfortable. Okay? All right, now let's keep moving. We did this one and we did this one, and we are up to step 4. Now, step 4, I've shown you what it's going to look like. What you want to do, let's see if I can go back here, and I'm going to grab this picture, copy, and we're going to jump ahead again to here. Now, you've already written some stuff on your paper plate. With your paper plate folded like this, what I want you to do is I want you to take some scissors and I want you to cut out a little triangular piece. So that means once it's folded in force like this, you're going to cut a little piece out like this. Okay? So you're going to cut that out so that it cuts, one cut actually creates 4 little spots. So pause the video while you do that. Okay, now hopefully you pause the video so you can make your cut. Now I'm going to explain all of these other marks. Okay? Remember that the one cut here created all 4 of these when you unfolded it. So the distance from here to here, let's see if I can do this. The distance from here to here is the same as from here to here, and here to here, and here to here on your paper plate. That's really important for understanding your rectangle families. Remember, we've been talking about rectangle families. So if this is my angle here, and I'm doing this in yellow because you don't necessarily need to write this down, then this is theta. In order to figure out this theta, I'm going to go all the way here to pi, then I'm going to back up. Well, I already know this piece right here is the same size as this piece right here. Since it's the same, I can go all the way to pi, and then I can take off theta. But when we take off theta, the math operation we're looking at is subtraction. So this spot here is pi minus theta. Likewise, if we come all the way around to here and come down, I'm taking this piece here, which is the same as this piece here, and just adding it so it's my pi plus theta. As we've discussed already with the first lesson in the unit circle, all of our measurements come off the horizontal, not the vertical. So to figure out this angle right here, I have to go all the way around so I get to 2 pi. Then I'm going to take and cut this piece out. That piece again is theta, so it's 2 pi minus theta. So what you want is in all of these locations to write down your theta, pi minus theta, pi plus theta, 2 pi minus theta. That's how you get angles for a rectangle family. The ones you're responsible for knowing are your coordinate plane one, or your unit circle ones. Those are your 30, 45, and 60, along with the quadrantals. Now, if I know the point right here, and I know that's AB, then when I move over here to this point, again, I'm putting that sort of out in space where the cut is, then that must be the point negative AB. Why? Well, notice the Y value is the same. The X value, when you fold your paper plate in half, this point is as far to the left as this one is to the right. Likewise, if you were to fold your paper plate in half, going this way, then you would find that this is as high above as this is below. So if this is B, this must be negative B. And likewise, the X coordinate is the same. Over here, my X coordinate is the same, so I have A. My Y coordinate is the same as the third quadrant, so I've got negative B. So you've now, using previous knowledge, prior knowledge, been able to not only find all 4 angles, but you've found the terminal point on the unit circle for all of those. So if I know this point, I can figure out my other 3 points. So far, so good? If you need to, pause the video so you can copy all of this information down onto your paper plate. Okay, you're back? Then moving on. Group activity 3. For this one, I'm going to go back and show you on the paper, but just in case you weren't in class so you didn't get this paper, let's take a look. Or you can do a screenshot so you can follow along. Right? First thing, using the terms pi, theta, and 2 pi, determine the lengths of each of the following arcs. A to P1. And by the way, this is P1, P2, P3, P4. It's the point in which quadrant. So, when I'm going all the way around, this length here, remember that arc length is equal, theta is equal to the arc length divided by the radius. Okay, theta is equal to S over R. So I know that R is equal to 1. Therefore, theta, my angle measured in radians, is the same as my arc length when I'm on the unit circle. Now, from A to P, this is theta. If that's theta, then from A to P2 is theta is pi minus theta. From A to P3, pi, so I get down to pi, plus theta. And A all the way around here to P4, well, that's just 2 pi. I've got to go all the way around to 2 pi and then take off theta. So it's 2 pi minus theta. Doing good? Again, this is all part of things that we learned already. Theta is equal to S over R. When we're on the unit circle, R is 1, so theta is equal to S. I'll put unit circle. So if the unit circle, theta is equal to S. Now, group activity 4. And again, if you're taking a look at this, okay, these are just questions that we ask in class. So I'm just going to go over these quickly with you so that you've got them. Oops, let me go back this way. All right, pause the video, take a screenshot. That way you've got what you need. Okay? Great. Everybody good? Then let's go back so we can answer these questions. Okay? What are the coordinates of P2? Well, here, and I'll put P2 is here, point in quadrant 1, quadrant 3, and quadrant 4. Well, the points, the coordinates at P2 are negative A, B. P3, negative A, negative B. P4, right here, A, negative B. And you got all of those because it's a family. What are the signs of the coordinates in quadrant 1? Well, the signs, X is positive, Y is positive. So it's plus, plus. What are the signs of the coordinates in quadrant 2? That would be negative, positive. X is negative, Y is positive. What are the signs of the coordinates in quadrant 3? Well, those signs are negative, negative. X is negative, Y is negative. Finally, when we get to quadrant 4, our X coordinate is positive and our Y coordinate is negative. Okay? Now, what are the coordinates of the terminal point of an arc length of 8 pi? Well, let's go. Let's see here. I'm going to do one of these guys. I'm just going to do a crayon, just because it'll be something different. And I'm going to start here, and I'm going to go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. I'm right here. So what are the signs of the what are the coordinates of the terminal point of an arc of 8 pi? Well, that would be right here, 1, 0. And what about 5 pi? Well, 5 pi, let's do a highlighter, okay? 5 pi would be 1, 2 pi, 3 pi, 4 pi, 5 pi. What are the coordinates? Negative 1, 0. Remember that even, oops, let's go back to pen. Okay, even pi's are over here, odd pi's are over here. Okay? Again, this is not, you're not supposed to write all of this stuff only these items are written on your paper plate. Otherwise, it gets too crowded. But you should be able to use your paper plate to answer these kinds of questions. Continuing on, step 5. Step 5 is just adding a little bit more information in here before you do your assignments. And that is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And then what I didn't put on here, just because it got a little bit crowded with typing, but this is positive, positive, negative, positive, negative, negative, positive, negative. All sine, tangent, cosine. All trig functions are positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are positive in quadrant 3. Cosine and its reciprocal are positive in quadrant 4. Now, you've got this whole thing all done, right? Let's see here. So now, if you take a look at this, and we've talked about this on the unit circle, okay? Here's this guy. We got this guy going. If this is 1, this is x, and this is y. I know that x squared plus y squared must be equal to 1. I also know that cosine theta is equal to my adjacent, which is x over 1, or just x. I know that sine theta is going to be equal to the opposite, which is y, over my hypotenuse on the unit circle, which is 1, or just y. Given this information, I can replace these with cosine squared theta plus sine squared theta is equal to 1. We use the Pythagorean theorem to create the Pythagorean identity. What I want you to do is I want you to write these notes, okay, on back of your paper plate. So on the flip side of your paper plate, you want to have a little picture that shows x and y, and then x squared plus y squared is 1. The fact that cosine theta is x, sine theta is y, so cosine squared plus sine squared is 1. Pause the video while you do that. And back again. Let's keep it going. Okay, this is where we start with assignment 1 after the construction of paper plate. Okay, so take a look at this, read the directions, and then I will work the first couple of these. Okay, if you've read the directions, let's take a look at this. You're being told that point 1 has 8/17 and 15/17 as its coordinates. Now all you have to remember is that point 2 is the negative positive version of this. Point 3, both of those values are negative, and point 4, the x is positive and the y is negative. Knowing that, if you do, remember you start at your anchor point, pi plus theta, you wind up at P3, which is negative 8/17 15/17. 2 pi minus theta, we go all the way around to 2 pi and then subtract off theta, and we are at P4. That point is 8/17 and negative 15/17. Pi minus theta, we go all the way around, remember right over here is pi, and then subtract off theta. That puts us at point 2, which is negative 8/17 and 15/17. Finally, 2 pi plus theta, we go all the way around back to our anchor point and add theta again, and we are now at point 1, which is 8/17 15/17. That's all you're being asked to do for each one of these. Okay? So you should be able to do numbers 2 and 3. They're the exact same thing. Okay? The exact same thing. So you want to try those, and then I've sent out or posted, I'm not even sure what's going on in the next year or so as far as whether we'll still be using Edmodo or what, but I will get to you the solutions for the rest of these. You move on to the next group. Now I'm going to tell you that point 1 is pi over 3. So here at point 1, we are at pi over 3. Now this is where you need to do pi minus pi over 3 makes this 2 pi over 3 is 0.2. Pi plus pi over 3 is 4 pi over 3, and that's 0.3. 0.4, remember, we go all the way around, so we have 2 pi minus the theta, which is pi over 3, so we have 5 pi over 3. Now, with that information, again, remember that these are both positive, negative, positive, negative, negative, positive, negative. Given the point, at 2 pi over 3, I'm at 0.2, and that means I've got negative 1/2 root 3 over 2. 4 pi over 3, that's down here. I'm at 0.3. Well, that point, they're both negative, so it's negative 1/2 and negative root 3 over 2. Finally, C, 5 pi over 3 is over here at 0.4, and that's a positive 1/2 and a negative root 3 over 2. These values should be looking familiar. They're part of your unit circle values. D, negative pi over 3. Remember that these are positive angles, and this clockwise is how you go for negative angles. So negative pi over 3 brings me down here to P4, which is 1/2 negative root 3 over 2. So for numbers 5 and 6, you're going to do the same thing, but you've got A to P1 is pi over 4. Okay, so you need to go around the circle and label things. And then number 6 is a little tricky in that they tell you that P4 is negative pi over 6. Well, if this is negative pi over 6, then this must be positive pi over 6. And if this is positive pi over 6, you can get over here to have your 5 pi over 6, your 7 pi over 6, pi plus pi over 6, and then 2 pi minus pi over 6 is 11 pi over 6. 11 pi over 6 and negative pi over 6 are what we call coterminal. Okay? They start and they end in the same place. You just get to them in different ways. Now, that's all well and good, but you still need to give me the points. The root 2 over 2 and the root 3 and the negative 1/2, that should all look very familiar. Unit circle values. Again, you'll get the solutions to these separately. I'm simply getting you started on them. Okay? Now, the next thing that you'll have with this particular activity is assignment 2. Assignment 2 is just more practice with unit circle values. I've labeled P1, and I've given you that P1 is pi over 6, but now you're using wrapping functions. Okay, the wrapping function. We've got 23 pi over 6. To figure out which point, or basically which quadrant it's in, we do 23 divided by 6 is 18. It's 18. Not 18. Is 3. Okay, is 3 with a remainder of 5. I was going to say because 3 times 6 is equal to 18 plus 5 more is the 23. So how many times will 6, the denominator, go into the numerator evenly, and then what's the remainder? You now know that this is 3 pi plus 5 pi over 6. Why does it matter? Well, you're going to start at your anchor point and you've got 3 pi. So you go 1 pi, 2 pi, 3 pi. 5 pi over 6, I'm sitting right here. I need to go 5/6 of a pi. 5/6 is more than a half, so I wind up in quadrant 4. Remember, pi over 2, going from one x-axis to the other x-axis is a full pi. So less than a half, you're in the close quadrant. More than a half, you're the far quadrant. So this tells me that this is 0.4. Negative 7 pi over 6, I have to remember, is going in this direction. So there's 1 pi over 6 minus 1 pi minus 1 more pi over 6. That's less than a half. So I'm in the second quadrant, or 0.2. Okay? Now, I'm not, with all of these, I'm not giving you the final answer. You've got to figure out those answers, but I'm showing you the wrapping function right now. The 13 pi over 6, well, that's 12 pi over 6 plus pi over 6, which is 2 pi plus pi over 6. I'm going to go 1 pi, 2 pi. Pi over 6 is less than a half, so I'm in quadrant 1. And then the 29, well, that's the same thing as 24 pi over 6 plus 5 pi over 6, which means it's 4 pi plus 5 pi over 6. So I do 1, 2, 3, 4. 5/6 is more than a half. So I wind up here at P2. The next two in this particular exercise, we'll do some additional practice with the wrapping function to figure out which quadrant you have wound up in. Once you know the quadrant, then telling me the ordered pair is easy. And again, you'll get those solutions later. You want to finish that up. In addition to everything else that you have, I believe I've also given you a chart that you can chart out all the values on. It's just, again, more and more practice. You've got to get lots of practice. If you have not already received, you will be receiving flashcards for the unit circle. They're to also help you study. We'll talk about how to use those in class. Thanks a lot.